Uh, okay. Hi, everyone. So yes, we'll have a few minutes talking about challenges and issues. I will talk about that. Jay will talk about um, EPSS performance, and then it turns into a Q&A. So with that, so as it turns out, so EPSS is relatively new. This information um, should be familiar to those of you who participate in the SIG, but I imagine that there are some people here and online who are not familiar with the SIG and what we do. So hopefully this should be new information. So EPSS overall is 4 years old. We have been producing scores, making them publicly available for about 3 years. So that's where we stand. So the first thing I wanted to do is to thank everyone. I wanted to thank our data partners. I've said before many times that EPSS is nothing without the data that we collect and use. It is also nothing without the SIG, the participants, and is nothing without the users, everyone who downloads the data and use them and ingest them in their products and consumes them. So thank you all for that. Okay, so ongoing challenges. So again, this shouldn't be new for anyone who regularly participates in the SIG, but again, I imagine a bunch of you are not familiar with this. So interoperability. So in the past few years, there has been an increasing number of both call them agnostic standards, so CVSS, SSVC, now EPSS, as well as vendor scoring systems. And so the interoperability here and the challenges relates to how how do we think users should or could integrate these different systems? So you as a network defender, risk manager of some organization, you hear about CVSS, you hear about EPSS. What is the best way for you to ingest these data along with all of the vendor scores that you're using from Qualys, from Tenable, and others? This is an ongoing challenge for us. Chris Madden has done a lot of really great work to come up with a user guide that is sort of tailored for his view, for his network, and for his context. And there's a lot of really great information available there. So I welcome anyone to go look at that. You can reach out to us if you need to find it or participate in the SIG if you want more information or join our Slack. But it still remains, there's a question about, as a SIG, as we are guiding this, how can we best prepare this information? How can we best guide different stakeholders, again, to use and consume the information? And we haven't quite wrestled with that. We haven't quite solved that issue. And probably, next year when we're up here talking about this will still be an ongoing issue. The probabilities versus percentile. So one of the issues that we struggled with very early on is that we produce, again, these probabilities, these estimates of probability for any vulnerability will be exploited in the next 30 days. Well, that's fine. And so we've got 230,000 of them, and that's great. And now we rank them. We include a percentile, which is really just an ordered ranking. What's the worst one? What's the next worst one? What's the third worst one? The rest of it. And so we hope that people will be able to recognize what these mean. That yes, they are actually true probabilities. And so now you can apply mathematical operations to them, and that's fine. But of course, as we know, people are not good at internalizing probabilities, at understanding what to do with those. And certainly becomes very hard when you are trying to differentiate the probability of a 0.00469 and a 0.00327, right? How is anybody really supposed to make any kind of sense of that? And so we tried to solve that a little bit by including these percentiles. So when you download the data, you get 3 columns, the CVE ID, the probability, and the percentile. And so we sort of hope and kind of assume that people will recognize what those numbers mean and do whatever they like with them, integrate into their vulnerability management practices and platforms. But we don't really know if that's working. It's tough for us to collect the information, to collect the insights from all of you, from other users, and find out if we're really doing the right thing there. or if there's more information that we can provide. As you'll see, if you've seen it by looking at the data, it's heavily skewed, and that presents even more problems. What we've tried to communicate, there's a blog post on the website. We try to communicate how the probability can give you a sense of a global uh, badness score, a global probability score that represents across the universe of the data that we collect and the scope that we collect, what is the global probability of this. Whereas the percentile may represent more of a local badness. So what you might do is in your organization, you collect all of the scores, and then you filter out those that don't apply to your network. And so while the raw probability score will not change, the percentile score will change, the rank ordering. Instead of dealing with 230,000 vulnerabilities, now maybe you have 50,000 or 40,000. And so the ranking will change. And so that's what we mean by the relative, a local badness kind of score. But again, I don't know if that comes through. I don't know if that provides useful intuition for people. So we're always looking for better ways to improve that scoring and improve the insights. And that leads us to these thresholds. So the story there is CVSS, as we all know and love, has a low, medium, and high, and a critical, right? Those provide useful guidance for us, or can provide useful guidance for those who need to triage different vulnerabilities. And so the question is, should we as EPSS adopt something like that too? Should we have low, medium, high, and critical? And there are benefits to that, right? It helps reduce it taps into our heuristics, our sort of innate ability and desire to reduce a lot of complex information into something quite simple, like a low, medium, high, instead of these probabilities. But it becomes problematic because of the issues that, if you've gone through this, you'll be familiar with, which is, where do you draw the cutoffs, right? I mean, that's what you need to do, is you need to assign some set of cutoff to that. Whatever that's going to be, and however that's informed, there's going to be a cutoff. And there's something about that that sort of rubs us the wrong way a little bit. You get into range compression, you get into this binning, and it's very arbitrary, and you can't really defend it. So how can we justify to anyone, even to ourselves, that really this is a critical versus this is a high? That's troubling. But it's also very unsatisfying, right? So we as the SIG, as the chairs, and probably for you as users, that becomes unsatisfying. So can't we provide some guidance to you? Isn't there someone who can provide some additional guidance and clarity onto how to use these scores? That's what we struggle with. And we haven't quite solved that. We can provide lots of data to you. Jay has done some amazing work to provide graphs and figures and charts to show you, oh, well, if you look at this, then this affects the number of vulnerabilities that you need to consume and prioritize. But if you think of it this way, then this does this. And that's really useful for those who want to take the effort and have the time to understand what it is we mean, what it is we talk about, what these trade-offs are. And so there's always this tension between providing more detail and more information to help those who are really interested, and less information, again, to provide more heuristic information for those who don't have the time or the ability to deal with more complex information. And so those trade-offs, I think, will never go away. I think we will always struggle with them. CVSS has gone through this over the years, trying to provide more detail, more information, but at the cost of complexity, at the cost of variation in skills, right? One analyst will score a vulnerability this way, another analyst will score it that way, when you start to give them the opportunity, all those different levers. So we haven't quite solved that. Data sources. So again, super grateful for all of the organizations that contribute and provide data to us. That's right. But we continue to seek more data sources. There are limitations with those data sources, of course, potential biases. Certainly, we don't observe all exploit activity across the globe, right? We just don't. We collect information from hundreds of thousands of devices across the world. That's true, but it's not everything. So there are going to be biases. And what's important for us is understanding what those biases mean in the results. How do they taint the results? How do they inform the results. When is EPSS more likely? When is it less likely? And that's important to know. And so we continue to solicit organizations, to reach out to organizations who either collect it for a business or just big organizations with big infrastructure who have the ability to maybe collect exploit data and who would like to engage with us. So by the way, if anyone is in that place, if anyone is collecting systematically CVE data and would like to share with us, we're all open to hearing that. But what we've learned with engaging with these companies is that they're just not instrumented. They're just not instrumented to systematically collect either exploit data generally or exploit data that is tagged with a CVE ID. And this has really gotten us to think about how hard of a problem this really is. Certainly, if you have an IDS, a lot, but not all of the signatures will be tagged with CVE IDs. Well, so now suddenly we're not working with the universe of all signatures. It's just those tagged with CVE IDs. And it's just for organizations that are able to collect those IDS or honeypot or whatever data, and now who have an ability to send them to us or to provide a feed somehow that we can collect. But it really does cause a problem and create an obstacle for us when we're trying to reach out to other organizations to collect more data, either even just broadly across the internet or within targeted domains or sectors, automotive, IT, OS, ICS, SCADA, stuff like that, right? Other networks, organizations, devices for which we don't have a lot of visibility. So that's an ongoing struggle. It's also true that because, because of the data that we collect, again, we are able to provide higher confidence around vulnerabilities that are exploited, right? This is good, right? We see that they're exploited today. We have all of the features that we collect about these vulnerabilities, and we can provide really good estimates. What we're not so great about is providing high confidence around vulnerabilities that are never exploited, right? If we've never seen exploitation at all, ever in any way, shape, or form, how can we reliably, as a data science issue, how can you reliably provide high confidence around the probability? And so that continues to be a struggle for us. But getting back to the CVEs, we are based just like CVSS. We are tagged off of vulnerabilities with CVIDs. If there's some weakness, if there's some exposure, if there's some vulnerability that doesn't have a CVID, there's nothing we can do about it. And we've tried to think of ways to how to expand what we provide to non-CVE vulnerabilities. Well, we can't really. And so what that creates is a bit of a call to the industry, a call to everyone else, first of all, to please tag all of the vulnerabilities, all the exploitation that you see with the CVID, right? That helps all of us out. And to share when you're creating signatures, when you're sharing the data through your intelligence networks, through any MISP systems, to include those CVIDs. Because again, that now provides us an opportunity to track them, collect the data, and again, provide more estimates. Outreach. So as I said, EPSS is still relatively new, 4 years old. I think we've made great strides, and Patrick, who has done some fabulous work at collecting a list of organizations. Thank you, Patrick. And thank you for dinner last night, by the way. I didn't thank you for that. Great. That's really great of you. Thank you. Has done some great work in collecting lists of organizations that are using EPSS, because obviously we don't know everyone who is using it but not telling us. And so we've made a lot of progress that way, but there is still more to achieve. Effectively, every place, what I would like to see is every place that provides a CVSS score would also provide an EPSS score. I think that would be a great situation. Excuse me, my phone is ringing. Somebody from California. And so we continue to do talks like this. We continue to do other outreach, continue to invite people to the SIG. We're growing the SIG, and it's all great. It's moving forward, but I still think there's a lot of progress to make there. Included with that is standardization. And so um, uh, this has been really interesting, sort of an interesting journey in terms of trying to understand if one is looking to standardize something, to be able to answer the question of, well, what is it you are standardizing specifically? Is it a technology? Is it a hardware? Is it a process? Is it a way of thinking? Is it a whatever, whatever? Um, so we have, and there are many standards organizations that standardize different things. And so one has to be very careful about approaching those different standard organizations in order to make sure you don't sort of paint yourself into a corner. That if you become a standard under one organization, does that preclude adoption, or does that present hurdles for other people trying to adopt and use whatever it is you're trying to standardize? So the ITU seems from our work seems to be a reasonable place to provide, to offer ourselves as a place to standardize EPSS. So CVSS is a standards, has a standard under ITUT. And so we think that would be a natural place for us. We presented a month or so ago at what is effectively a kind of a United Nations like forum in Geneva. And it was there was a lot of interest. There was a lot of excitement around what we had to say, but we came around, there were some questions about, well, you're trying to standardize this thing that is kind of by definition unique to you. So it's sort of a technology that you are standardizing, and that doesn't really sort of play well within this area. And it caused us to think a little bit about, well, okay, that makes a lot of sense. So what can we standardize? Could it be a way of adopting and using EPSS? And there may be opportunities for that, and we'll continue to pursue it. But that becomes useful for us, and I think for everyone else, to help adopt or to understand sort of the trust and increase adoption of EPSS. Let me say another couple words about what I think we've created. I think there are some really great insights that we've been able to achieve with these data, again, through a lot of the work that Jay has done in being able to answer questions that we as a community haven't really been able to do before. So now we have a good understanding about, well, how many vulnerabilities actually are exploited in the wild, right? If anyone had asked that question, if I had asked that question 5 years ago, I wouldn't know how to answer it. I wouldn't even know where to go to be able to answer it, because I don't think those data were being collected before that. Well, maybe they were, but there was nothing public about it. And so we as a community really had no insight, which kind of seems strange, because I think a lot of us have been around for a while, 20, 25, 30, 35 years, and yet we still don't have even those basic answers. So anyone who went to Jay's talk would have had, all kinds of great insights taken away from that. And I encourage you to listen to the talk. It's available on the FIRST app. You can go watch it. But now we have some information about how many total vulnerabilities are exploited in any given time period. We know how many unique vulnerabilities are being exploited. We know the characteristics of those vulnerabilities by vendor and by type and the rest of it. So now we're starting to achieve a little bit better insights into that. We also have, again, the realization that, well, of these 230-odd thousand vulnerabilities that we know about, we collectively, through IDSs and honeypots, are only really tracking like 10% of them. There aren't signatures for 230,000 vulnerabilities. There's signatures for like 10,000, 15,000, 20,000. We're not even looking for the rest. Now, one might ask the question of, well, does that matter? Like, do we care about those other vulnerabilities, or should we be looking, in fact, at those other vulnerabilities? And even I can't really give you an answer for that. I guess what I've kind of managed to put together from different people who've been embedded in this area is that, well, those others aren't really that threatening. We don't really care so much about them because they maybe affect some particular app that only 4 people use, or some end of life application, whatever. But that's important to know. So as we say that, approximately 5% of all vulnerabilities are ever exploited, Well, that's in relation to all 230,000. But if in fact a large percentage of those are really kinds that, aren't really worth us looking at, then maybe the answer is not 5% or 10,000 out of 200,000. Maybe it's 10,000 out of 50,000. Maybe 100,000 of these vulnerabilities are those that we should all just forget about and maybe not even track anymore. But I don't even know what the answer is to that. Hang on a sec, just let me. Um, but those are important insights, right? So now, and for anyone who went uh, uh, to Ben's talk yesterday, talking about CVEs and CV inflation and this ecosystem between vendors, researchers, CNAs, and then now we're starting to have a better understanding of how these vulnerabilities are kind of created, as it were, and how a CVE ID is attached to them. Well, we start to wonder, well, are all the incentives aligned here, or are we just creating an ecosystem that is maybe doing more harm than good because of this inflation? Are we now forced to track all of this stuff that really we should not really worry about? Those are important insights. Um, um, and I think this is good for all of us to have these kinds of moments of awareness and enlightenment about what this ecosystem looks like. And so that's good, I think, for everybody. And we're, of course, happy to share, whatever we can with you in these reports and again on the SIG and through presentations. There are also still a lot of questions that are unknown. What I hope, my hope since day one, is that all of this can lead to better understanding of attacker behavior. Again, what I think we fundamentally lack as an industry, as a community, is the ability uh, to think up and to test theories of attacker behavior. We have some information about the outcomes, about which vulnerabilities are being exploited, but we don't know why. I can't tell you why it's these vulnerabilities that are being exploited as opposed to those. And I might submit that nobody in this room can. We might have ideas, we might have sort of, thoughts about that, and that's great. But can we test that in any kind of meaningful way? I think we as a community lack that ability. And what I really hope that EPSS provides is an opportunity for, maybe some of us or future researchers to go and investigate that more. We also haven't yet gotten to vulnerability chaining, right? Chaining always comes up. It's not just one vulnerability that's exploited in some incident, it's potentially many. But we sort of don't know how many times, and we don't know which vulnerabilities exactly. And so the question is, can we, from looking at our exploit data that we collect, figure that out? I don't know. Maybe we can. We can certainly look at correlations, but we haven't had the opportunity yet to go do that. We have a running list of 30, 40 odd tasks, and honestly, we just haven't gotten to it. So if there is any enterprising young or old individual who would like to get into that and help us out, we would welcome it. Otherwise, it's going to be on our list for a while, I think. And we can't yet prove to you, I can't prove to you that if you start using EPSS today, it reduces your risk. I would like to think it does. And I guess I would sort of hope it would. So if you're able to fix these vulnerabilities that we think have an estimated higher probability of being exploited, I would like to think that it reduces your risk. But I can't tell you objectively that it reduces it more than if you were to not use it, or if you were to use it this other way, or if you were to use it in some upside down something way in combination with other thresholds or scoring systems or whatever. Right? I can't do that. I might submit that nobody in this room can. But it provides information, some insight about sort of the level of awareness and capability that we as an industry have, that we can't answer these basic questions. Now, in our defense, that's probably a bridge too far, that EPS isn't designed exactly for that. But we would like to think that, over the years, as we develop more capabilities, we can start to get at those kinds of insights. Okay, I will stop there, and I think Jay has some more slides.
Okay. Should we open for questions at all for you?
Sure.
Did
you have a question?
Yeah.
There was one question.
Yeah, a question of clarification. Say 5% of the vulnerability is exploited. Oh, thank you. When you say we know that 5% of the vulnerabilities, or whichever number it was, I think that what you were trying to say is 5% of the vulnerabilities for which we have data.
Yes.
That we have evidence. Yeah.
Yes.
For which you have
yes.
evidence.
Yes.
Because, and it goes back to what you said before, not CVID, not getting the report, getting biased information. So it was just a small correction. It's not 5% of 230,000 vulnerabilities. It's 5% of the 20,000 for which you have information.
Yeah, and yes, it's exactly right. Go ahead.
Well, the denominator that we're calculating 5% on is the 230,000. So it's 5% out of 230,000, which is 13,000 that we have CVEs with known exploitation activity on. So out of the 50,000, that would be what, 26%.
But his point is that if we only have signatures for 10,000 of them or 20,000 of them, there is no way we're going to be able to detect those other ones anyway. And yeah, I mean, that blew my mind when it finally hit me. Why don't IDSs have signatures for 230,000 vulnerabilities? Well, A, it's hard to do, right? There are humans involved in this, and they have to write signatures for all of those. But the recognition, again, might be that most of those we don't need to worry about. Nobody cares about because they're not impactful, they're not threatening, they're not whatever. And so, okay, well, if that's really true, then maybe our denominator throughout all of this should not be 230,000. It should be some fraction of that. But I don't know what that fraction is. I'd really love it if someone could tell me what those are, because I think that, again, would help us make better informed decisions and help create better understanding of what's going on.
Now, going back to the data sources, and you were talking about more data sources or better data sources will make the results better. My question is, when you provide this probability within the next 30 days, and this is an assumption, I assume that you're getting data constantly from your data sources. Do you ever, guys, actually review the probability that you issue 30 days ago versus the data that you're getting now?
Yep, that's part 2.
Okay.
Yeah, we got some plots coming up.
And again, that's an obvious question that I think a lot of people don't go through when they develop these models. Like, so you made this prediction, great, good for you. But have you gone back through to check? Well, Jay has done that. Okay, over to you.
All right. Okay. Hopefully I can just grab this and wander around. All right, so you had a couple of slides here, Sasha. We will start here. All right, so first there's a large challenge in talking about how is EPSS performing, because how do you measure it, right? There are numerous ways that you could approach it. We're going to take the stance of these 3 variables, the amount of effort. And unfortunately, I think in an organization, the amount of effort is how many vulnerabilities across your assets are you going to prioritize? And in our case, we don't know that. All we have is the number of published vulnerabilities. And so that's what we're going to make our denominator when we talk about effort. So in the prioritization strategy, we may say we're going to prioritize 10% or 20% or 2% or 50%, something like that. Efficiency is the next one. I'm going to walk through these in more detail, but essentially, what percent of those that we're going to prioritize were exploited? How efficient was the dollars that we're spending on remediation? Right. So if we say we want to prioritize these 100 vulnerabilities, and we're going through that motion, 30 days later, what proportion of those were actually had exploitation activity? That's the efficiency. You know, if you did 100 and 100% of those were exploited, that's 100% efficiency. If 10 out of that 100 were exploited, that's 10% efficiency. Coverage is basically what most people want to study. How many of those that were actually exploited were prioritized, right? And that's really what companies want to do. You want to go after the things that are going to be exploited and or are being exploited and remediate those. And that's really the main metric that companies probably want to work to. Now, if you're a smaller org and you've got a really small budget, you may value efficiency more. You may want to make sure that every dollar you spend is going towards something that is likely to be exploited. So let's talk about what that means. Basically, in this chart, we've got the big circle of all vulnerabilities. In the data that we have, we've got this red circle that says these were exploited. In this case, I did from December 1st to December 30th. This red circle represents all the CVEs that were exploited. Now, if we look at the data and we say, all right, we're going to go after CVSS 9 and above, right? This is our strategy, 9 and above. We're going to create this blue circle. Now, if we look at the overlap between CVSS 9 and above and the red data that we saw with exploitation activity, this is what we see. We see an overlap like that. So if we talk about efficiency, efficiency looks at that blue circle and says, out of all that 100% of that blue circle, how much is covered by the red? And then coverage is the red circle, how many of that is covered by the blue? We can walk through this a little bit simpler though. So in information theory, you have the true positive, which is the overlap of the two, a false positive, things that you're prioritizing that maybe could have been delayed, the false negative, the things that you're missing that were in fact exploited, and then the true negative, things that you didn't prioritize and was not exploited. So let's walk through what this means. Effort is basically the size of that blue circle relative to the gray circle, right? You're going to go after, I don't know what this is, maybe 15% or something. Coverage, like I was talking about, is the exploited vulnerabilities that red is covered by the blue. And you can see the actual formula there, true positive over true positive plus false negative. Efficiency, like I said, this is the formula. We've got the true positive, that overlap over the size of the blue circle. All right, this is just a view. This is an older slide, December 1st of 2022. I grabbed the data, various attributes that we saw on vulnerabilities. I looked at the exploitation activity in the following 30 days, and I created these plots. So in the far left for CVSS 3.1, we've got privilege required none. That is going to prioritize 70% of the CVEs. 7 out of 10 CVEs are marked with privilege required none. You're going to do a lot of work, but you're going to have pretty good coverage. 88% of those being exploited would be prioritized by that. If we go further to the right, say exploit DB in the upper right, only about 11% of the published CVEs have something in exploit DB, and you're getting a coverage of 34%, so roughly 1 out of 3. But your efficiency is much better, 13% versus 5% on the CVSS privilege required none. Now, I think 2 interesting things here are in the lower right where we talk about Metasploit and Kev. And again, this is like a year and a half ago, but it's still holding up. And I've got some slides I presented on yesterday where I show what they look like right now. But in Kev, we're seeing the effort is 0.5% of all CVEs were on the Kev as of that December. You get about 6% coverage. So about 6% of all the CVEs we saw exploitation for in the following 30 days were on the Kev. And the efficiency was 53%, meaning that if you did everything on the Kev, only 53% of the things on the Kev that we actually saw exploitation activity for, right? And there's all sorts of caveats in here, right? Did we have signatures for it? Were they actually being exploited somewhere else rather than the sensors we have? All these things, right? But if you look at Metasploit, it's double the effort, 1%, so it's a blue circle's bigger, and you have 14% coverage compared to 6% on Kev, and the efficiency is better, 60% efficiency. So at this time, and actually still to this day, you would have better results just remediating and prioritizing things that have a Metasploit module than following the Kev, according to this data, right? So this is sort of a high level. This is what actually we predicted EPSS v3 to do. So this is taking those same data points, the coverage and the efficiency, and putting them on a scatter plot. Now what we have is across left to right here is coverage. So on the very left, you have 0 coverage up to 100% coverage. Going up and down, you've got efficiency, 0 to 100% efficiency. And so we want things to be in the upper right. We want these lines to be pushed to the upper right. And they're lines because we have a continuous number. So EPSS is a score between 0 and 1 or 0 and 100%. And we basically like, where do we set that threshold? So this is what Sasha was talking about setting that threshold. So if we say, for example, let's pick one 0.5, 50%. If there's an above 50% chance of exploitation, right now we're publishing V3 scores, which is that red line. So if we actually go back in V1, which was 3 years ago, 0.5, you're about 10% coverage and 65% efficiency. In the version 2, which we replaced last year, that's what, going up to 23% efficiency or 23% coverage and just over 70% efficiency. We're getting better. And the last model improvement, we made really, really big improvements. Now at a 0.5, you're getting 60% to just under 90% coverage with that. And then for here, I put CVSS on here, and we have all sorts of debates about how much do we talk about CVSS, things like that. CVSS was not designed for this. This is only the base score. This is not necessarily a reflection of CVSS, but if you used CVSS base score to try and predict exploitation activity, you sort of get this flat line along the bottom. And like if you do 7 and above, it's over to the right bottom. That's a high effort thing. There's a lot of effort to do 7 and above. It's like 57% of CVEs are 7 and above, over half. So, and this actually tries to capture that. So if we take CVSS in the upper left and say 9.1 and above, basically 15% effort, right? We're going to get 33% coverage, 6% efficiency. Now, if we go down to the lower right, I maintain the size of that blue circle. If we can do 9.1 and above, and we can handle 15%, we can handle 15% on EPSS too. But now instead of 33% coverage, you're getting 90% coverage, and the efficiency goes from 6% to 24%. So you're getting a lot more efficiency and coverage for the same amount of effort. Along those same lines, if we manage to hold the coverage the same, if we want the effect, right? The effect of doing something like CVSS 7 and above, all highs and criticals. What we get for CVSS in this is 82% coverage, which is great, but the efficiency is pretty poor at 3.9% because it's a huge blue circle. Like I said, it was like 57% of all data, all CVEs are 7 and above. But when you go to EPSS, you can maintain that 82% coverage for an effort of 7%. And the efficiency now goes to 45%. You can see that blue circle is much, much smaller, the amount of effort that you're going after. The threshold is 0.088. This is actually version 2 when I did this. And so the CVSS version 3, the effort there is 58% to 7.3% at a threshold of 0.088. So if I go back to this slide, 0.088, 0.08, just above that 0.5 or so, coming down the red line on V3. All right. Now we talk about this being a true probability. And one of the things we can talk about is a calibration plot. Basically, if we say something has a 20% chance of exploitation, we expect about 20% of those to see exploitation activity. This is how probabilities work, right? If you say you've got a 50% chance of heads, we flip a coin, roughly half the time we should get heads, right? With some variation. That's what we're saying here. And this is a way to look at that. How closely are these probabilities reflecting the true average? And we're seeing them match pretty closely along the scale here. And so it's how we know that we're producing interesting probabilities that'll be helpful. All right, now this is, to prepare for this talk, I really wanted to get current data and bring everything up current and talk about performance. And so I created this visualization. And what this is going to do, it's going to go through various days. It's going to start in April of 2021 when we had V1. This is version 1. And you can see we want to be in that upper right again. You sort of remember the 3 lines I had in there. This is going to scroll through and show each day as it's performing. So you can see things move around. We're seeing some things, various things drop and come into the data. We saw it jump down. We had some data collection problems, and we had less data, so it actually didn't perform as well when we measured it. Here's the red line at V2, again, moving around a little bit, jostling around. And then we put out V3 early in 2023, and this is how it's performing. And what this is doing, we're literally taking the scores that we publish, the things that everybody can go download, and then we look back in time and say, a month ago, 30 days ago, we made this prediction. here are all of the things that were exploited. How did we do? And we create these lines, these precision recall lines, the efficiency covers lines. And we're actually looking at that performance, and this is how we're doing. And then I connected the various thresholds in this one just to see how it goes. Now we can take this same thing and show all of these at once, and this is basically how things are performing. Now the question is this good, right? Because what we can do, anybody can go do this. We can go look for a low scored CVE or even a handful and find evidence that the low ones are being exploited. We can look at a high rated one, find that that is not being exploited, or we can't find evidence anyway, right? Does that mean this is broken? No. And the reason is because we want to compare this to something. If you had an analyst sit down and say yes or no to all of the published CVEs or some subset, you could compare how that analyst predicted to this. And that's what we want to do. We want to say, what else can we do? Can we, just go after Kev? How would Kev perform? And Kev is towards the left, up. It's just a point because it's binary. It's yes or no rather than a line. As to the left, it has low coverage, but very high efficiency. Right? And so this is how these need to be measured. You have to measure these to say, what is our best option? What is the least sucky thing we can do? Right? And hopefully EPSS could be a part of that. But we can measure it. And this is, again, against the data that we have. And we do various things to try and not make it bleed over. But and this is how EPSS has been performing. And with that, I think we can open it up for questions. I've got a ton of slides after this. Hopefully for any questions that come up, I could answer it with some slides, hopefully. But anybody have questions? Out in front here. Did you just sigh before the question? Or was that? That's a good sign. That's going to be.
I read documentation on the first EPSS area and also the papers that you have published. And one thing that surprised me, we took the EPSS score for a subset of vulnerabilities across time. And one thing that surprised me is that the EPSS score, it didn't vary very much across time.
It didn't move around much?
It didn't move around.
Right.
So when I look, and not all the data is available about the underlying data model, how the weights are being applied to arrive to the EPSS, would it be correct to say, based on the evidence and the weights assigned to different variables, that actual exploitation varies the score or affects the actual EPSS very low, very little?
I think I missed that last part.
Let me say in a different way. The actual EPSS score is mostly defined by inherent characteristics. There is a metasploit, that actual exploitation evidence.
Yes. Yeah, so EPSS, very intentionally, does not predict the score based on like recent exploitation activity with a caveat. So when we're actually producing the score, if we built that model to say an autoregressive model saying like this CVE had exploitation activity yesterday and the day before and the day before, right? And so we built a model like that. And what happened is the model was really, really good at saying what we have exploitation activity for. It was really good at that. What it was terrible at is talking about the CVEs that we didn't have signatures for, right? So we could say, I mean, we could also say these have exploitation activity, but then what about the ones that are probably exploited that we don't have a sensor for, or that nobody's looking for, or the attackers just aren't hitting it, or it's something where it's really easy, and so nobody, like SQL injection. A lot of the WAFs and IPS will write, here's 3 SQL injection rules, and we're going to capture 90% of SQL injection. We'll never associate those with CVs. Right? But then we can say, hey, that we've got evidence that people are talking about this. We've got some exploit code on GitHub or whatever. We're seeing signs that this particular one may be important. We will never see it exploited. And what we didn't want to do is to ignore that and just look at the ground truth, the facts, and say, if it's exploited yesterday, it'll probably be exploited tomorrow. We didn't want to do that. So we wanted to kind of blur that. And so that's why you see things like with exploitation activity might be rated low, because it's kind of weird this is being exploited, given all the attributes that we're seeing and things like that. Now, you also mentioned that the scores are relatively steady, and that is true. And in fact, they're steady if things don't shift. And the other thing that I hear that people complain about is that the scores do move, right? Because people want to know, they want to plan out their things, they want to know what they're going to go after and remediate. And then and all of a sudden this one jumped up and it was really high probability. Now we have to jump and move. And I was like, yes, like exploits are showing up on exploit DB and Metasploit that's now in a nuclei scanner. Shodan now added a scanner for it. These are things that you want to react to, right? So if things aren't moving, that's kind of good. Maybe there's not a lot of activity around there. But if things jump around, you do want to react to it. Did that kind of get to what you're after?
Yes, but how much can they jump around based on the exploits, the certified exploit or the observed exploits, considering that the highest weight for the total probability score are variables that are set from the beginning? Or well, let me clarify, yes, there may be not Metasploit exploit at the time that vulnerability became public, but once the exploit became available, that's not going to change.
I think I missed that last part.
Exactly this.
Exactly this, yes. So this is a list of variable importance. And this is going to get this is a fun discussion. So at the very top, the most contributing variable is if you look up a CVE and you count how many references there are, that is the biggest indicator of exploitation activity. Which is, in my mind, when I saw that, I thought, this is ridiculous. This is absurd. Like, this is a super easy thing to do, and it's going to be better than having that be a remote code execution or being on exploit DB or anything like that. But it actually turns out to be true. If you go look at any log4shell, you go look at it, I think it's well over 100 and some references on that thing right now. It is insane. The average number of CVE right now, I think, has 2 or 3 references. If you see something with 10, that means that there's a lot of chatter. People are talking about it. There's blog posts, there's more advisories, things like that. And that's a good indicator. But, and here's the big problem, the weight for each of those is not static. The weight for the number of references is not a static thing. The model that we're using is XGBoost. And what that has is essentially the effect of interaction effects. So the fact that something has a lot of references might be meaningful or more meaningful if it's a Microsoft vulnerability on an internet-facing service. It might be less meaningful if it's on CD burning software that nobody has anymore or something like that. So like the value of any individual variable is going to be dependent on the context of all the other variables, right? And so this is a view of, if you look at the age of the CVE on the 5th line, the orange blob, most of it doesn't really matter. Maybe it's a little bit less, a little bit over. The fact that orange thing is so long means that in some context, that age is very important to either increase the probability or decrease it, and it's dependent on all of the other variables. Does that make sense?
Yeah, I didn't know that. Actually,
Yeah.
didn't. I thought that the weights were static. I didn't.
Yeah. And so they kind of are static, but in context.
Yeah.
And so, and this is part of the beauty of XGBoost. I didn't make this up. This is a lot of people have established this. So, and this is part of the challenge too, that a lot of these basically have very little effect. Like there's 1,400 variables that we're looking at in EPSS, and you pick any one of them and they almost contribute nothing until they do, right? So you might what's a good example? Like Shodan, for example, it's not on here. I did this before we added Shodan, but Shodan, I think, is scanning. They have 2 different types of tests in Shodan where they're more confident, where they actually go try and poke that vulnerability and make sure it's present. Another one where they just look at the headers and things to say looks like vulnerable software. And I think in the one they're poking, there's under 100 or something, like it's a very small number. And the ones that they're just grabbing headers for, there's like 1,200 or something, a lot more. right? And so like out of the 230,000, we have maybe 1,000 that has information there. So most of the time, Shodan is zero. We don't see Shodan, but when we see it, it may be really important. And it may be more important depending on other variables that we see for that. Yeah. There's another question back here. Yeah.
Hey, there's something I don't understand. When a vulnerability is in sysakev, doesn't it mean that it's already exploited? Why shouldn't it get just one EPSS score, like 100%? It's already exploited.
Right. So when it's on the kev, doesn't mean it's exploited 100%. Does it?
That's the definition of sysakev, isn't it?
It's known to be exploited, past tense, right? Is it going to be exploited in the next 30 days? Does the kev tell us that? Now, and part of the things I was talking about yesterday in my talk, out of all of the 13,000 CVEs that we saw exploited, 25% of those have not been exploited in the past year. 1 out of 4 have stopped being exploited. Which 1 out of the 4, right? We look at the kev, we see, yes, here's a list of CVEs. The kev is what, a year and a half, 2.5 years old? I don't know. But are all of those still exploited?
Yeah, but if something was exploited, it's mean that for sure it's possible to exploit it. Isn't that the goal of EPSS, to tell you what is going to be possible to be exploited?
Oh, everything's possibly to be exploited. Yeah, and things that have been exploited have a higher probability of being exploited in the future, but are they? And that's what EPSS is trying to do. So kev, we did not put it as a target variable. It is in the input, essentially saying, hey, someone is out here in a field yelling this is being exploited. Let's see how well that predicts our actual exploitation activity.
Cool, thanks.
Right? And this is hard because we get a lot of data sources like that, or we see, hey, we know that this CVE is being used in malware, and then we want to know, when is that malware being seen? Is that active? Is that really active? Was it active 2 years ago? It's really hard to take that exploitation activity and to say when, because EPSS is all about looking forward. Is this going to be exploited in the next 30 days, right? Which is really hard because kev is like, we saw it exploited and they don't really say how or why or how much. Was it widespread? Was it all over the place? Or was it like one device in one place that said yes? Or was it like a vendor saying that they read something and feels like it should be exploited? So in their blog post, they said it's definitely exploited. And then they picked that up and said, oh, it's definitely exploited. Let's throw it on the kev. I don't know. It's somewhere among all of that, right? So, but we treat it, we put it on the right side. So if kev says it is exploited, I think they're on here actually. Cite kev towards the bottom. You can see it's like 4th from the bottom. And it's really close to nothing. And this is both positive and negative. So when it's not on the kev, maybe that's coming down a little bit. It's a little bit below 0. So it might reduce the probability if it's not on the kev, but might require more research. Is the mic on?
Couple questions for you. Looking at the EPSS spec, it says software. Have you thought about expanding beyond software to firmware and hardware? And, at least my findings is as you go lower in the stack, it gets harder to exploit. And that's the first one. And then what do you think your percentage of accuracy is? And thoughts on how to improve it?
Yep. Okay. So the first question, moving lower in the stack to like hardware and things like that. If there's a CVE published, we produce a score. So there are CVEs on hardware and things like that, operating systems, even IoT devices, ICS is in there. And largely EPSS is ignorant of all of that. And I think this is, on one hand, it's super easy to write a model then because we don't have to pick and choose or try to do things. But I think in the future, What we might want to try is to build EPSS for AppSec, EPSS for IoT devices, for vehicles. I don't know. Whatever we can do, there might be benefit to trying to slice out different types of vulnerabilities because they're different ecosystems, right? How applications are being exploited is much different than hardware. Right? Security as a service, you have to move faster. Yeah. Yeah. And so that's good. That's a challenge. Right now, we treat it all as one. I think it'll be interesting as time goes on if we can really dig in and say, we want to focus on this. We want to focus on cloud or something. Now, the other thing with CVEs is that I would love to do non-CVEs, but we all suck at naming things, right? And so like if someone comes out and says, hey, there's this problem in this D-Link router, we don't have a CVE for it, and then I go look at exploitation activity and they're like, D-Link 40489 saw exploitation activity, and there's no way for me to programmatically or systematically know that what they're calling this is this vulnerability over here. So that identifier allows us to bring together disparate data sets, to pull out meaning from this is saying this ID and this says this ID. They're talking about the same thing. When we don't have that ID, it becomes nearly impossible to do it at scale. And then your other question about the accuracy. So accuracy actually has a meaning in statistics, right? Out of all of your guesses, how many were right? In fact, you can get about 95% accuracy if you say nothing is exploited, because only about 5% in this data set is exploited. So that's really good accuracy just by saying no, right? And so accuracy is hard. Hopefully the charts that I was showing says, here's the performance. How to improve it? This is exactly what we're working on. We want to try and improve it, make it better. You saw the improvement from version 1, 2, and 3. We're pushing things in the upper right. We want to keep doing that. And there's two ways we're going to do that. One is better data to get more exploitation activity, more visibility into that. And the other one is to get more descriptive data about vulnerabilities. How do we dig in more and more to find out what these things are actually doing in the ecosystem? And then there's a slight third way to improve our modeling, but that's a different topic. So.
When you were, I think that previously the gentlemen were talking before you about adding or, combining data sources, et cetera, would it make sense once you have the EPSS score for a CVID to try to augment that data? You were talking about also binning and setting thresholds and how that, but it will make sense to try to augment with other data sources like KEV or components of the CVSS base score like network when you're already considering those within EPSS and correlating with the other variables. Does it maybe make sense to then try to add them again into the mix?
Could you restate that? I kind of lost a little bit.
So you have the EPSS score.
Yeah.
For a given vulnerability, for a given CVID.
Yep.
And now you want to even more try to separate which ones should be the ones that out of 0.99 probability and all of them are in 0.91 percentile. Now you want to find, okay, out of these 5, which ones will be the first?
Right.
Okay. So my question was, you could add to the mix as another data source, is it present on KEV? Or you could add to the mix also, well, it's exploitable from the network with no privileges. But my question is, does it make sense to add that again if it's already part of EPSS and being combined with the other variables?
I might take it a slightly different direction. Let me know if I go in the wrong direction. But so EPSS is just looking at what's going on for exploitation activity. All of these vulnerabilities have a context, right? They are in an asset somewhere. Like you said, it might be internet facing or something like that. Like all of that. So one of the challenges is that EPSS should never be a decision. It shouldn't make your decision, but it should feed a larger analysis process. So like, for example, if you have your crown jewels and it only has low rated vulnerabilities, you still may want to do those just because any probability of exploit on this machine or whatever is way more important than, the cafeteria menu system that has high EPSS or something. Like the context is going to change your attitude about remediating those. Did I take that in the wrong direction?
So it will be basically, instead of trying to add in additional data sources, doing, as an example, SSVC on your assets, and then augment that with EPSS. So once you define the values of your assets, take EPSS to define which ones should be protected first.
Yes. Yes. And so as EPSS doesn't know the value of your assets.
It's impossible.
Right? And so there's nothing that we can do at a global scale that we're dealing here. So, but hopefully, like, and we talk about this in a lot of our documentation, that there's basically, if you know there's exploitation activity in your network or near or whatever, go after those. If you don't know, go to EPSS and then start to factor in, the assets, the compensating controls, the type of data you have on there. Do normal risk analysis stuff on these, and however you're prioritizing now, right? And this is one of the early criticisms about the model, to say that EPSS stops and it doesn't do the context and things on the thing. And it's like, well, we didn't actually stop. We can't do that. My car also doesn't fold my laundry, but I don't blame the car. So this is all we're doing. We're looking at exploitation activity and predicting that. We cannot help you rate your own assets and prioritize internally. So.
And one hopefully final question. Did the model for EPSS version 3 come from observing the data, or did you guys come up with the model and then basically the model confirms what the data was showing?
It's machine learning. And so we allow the machine to learn from the data, right? There's zero human in the loop here. We do not look at a variable and say, this should be a 1, this should be a 2. There's no humans in the loop. It's the machine saying, and that's why we get these interaction effects, because the machine is able to say, I see this is important and this is important, but they're in the same one now. Now it's extra important. We get these emergent properties in the data coming out. So we don't do anything. We put it together and have the machine do a whole bunch of complicated pattern matching, pattern recognition stuff in there. And that's what the XGBoost model is doing for us. Yeah. And that goes for all of the data. So another question written here. Yeah. What? Sorry.
Hi. I got a ton of data science nerdy questions for you, so I'll come afterwards because I don't think many people will find that interesting. But the challenge for me as a builder is, how do I get my operators to trust EPSS on a recurring basis? When they look at the vulnerability intelligence platform, they see a binary 1 or a 0. If they see the 1, they click on it and they find out more details about it. With EPSS, we're just giving them a score, and there's not an explainability of how it got there for them on an operational perspective. So other than just saying, trust me, bro, what can we do for the operators to help explore that for them so they can garner trust in what they're seeing? As well as, now that I know these things, Jeff, I want to add these 3 things because I think that's more important. And then I can go add that into their model so I can have a custom model for them.
Yeah. So building trust internally around this, I think, is a challenge. I don't have a great answer. The only thing I can say is we're trying to show how it's performing. And of course, rarely do people have actual exploitation activity to compare it against. But if you could, I don't even know. I mean, like, have an analyst maybe rate a bunch and compare that to EPSS, and you don't have any ground truth, though, to say how that's performing. I don't know. Do you have any solutions yourself? Like, have you had any luck?
So where I see a huge opportunity that doesn't exist with vendor-based scoring is vendors traditionally make those black box.
Right.
If I can reproduce your experiments and work with the security engineers to show them how it got to where it's at and allow them to customize it with their internal intelligence feeds, that provides them the information. And then I can even take 3 different engineers, I have 3 different opinions, and start building in score methodology, say, hey, who would work better to the left or the right under XYZ circumstances? And now I'm engaging them in the conversation. I'm applying their subject matter expertise. And it's not a trust me, bro. It's an inclusive operation.
Right. Yeah.
Yeah. So the issue, so that could have been another bullet that I talked about, is transparency. Right. We first described this as, this was a volunteer, community, open effort. Well, it's sort of open. It's kind of open. When we first started this, it was a logit model. That's what we were running, just a plain regression with a logit. And it worked great. And you've got all the transparency you want. Here's the model. Here are the coefficient estimates. That's all you need. And then we moved to the machine learning because it performed better. Because at the end of the day, we put more weight on the performance of the model than on the transparency. So that was a decision on our part. And so, yes, it's natural that people will come to us and say, look, you provide a score. How do I know that's the right score? And we struggle with that, right? So we've written papers. And we provided as much detail as we can on all of the data that we ingest, the number of features, the kinds of features, um, the curation of that, the data engineering, all of these slides that Jay has put together, all the statistics and performance, all of that, all of that, all of that, all of that. So we keep doing that in order to help demonstrate, oh, why here's you should trust us. Now, there would be no way for you to reproduce this because you're not working with the same data that we're working with. You could collect data in your organization and uh, and create a similar model, right? An XGBoost, and you would probably come up with different results, but that's to be expected. Now, we could also go to the next step and show the code. Oh, okay, well, here's the code, but I don't think the code is really going to help you because that's just showing like, oh, look, we ingest this data, we do this transformation and blah, 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 and then we run through XGBoost and here you get the results. Well, that's not going to help you. So again, we struggle with this, right? We struggle to figure out how much transparency to provide. And so we continue to provide more and more and more with more of these slides. But it's not a perfect answer. At the back, yeah.
Are you aware that the CV count of references is not reliable anymore because there is a kind of a pause on the secretariat not adding the references that have been web scraped, unless it's something that's MITRE has assigned.
The references do come from MITRE.
No.
Are you saying that MITRE stopped their process?
For the CVs that have been assigned by CNA?
Okay. So, no, I had no idea. So this is another problem in doing this. Like, we are not superhuman, and we absolutely have data fall out from underneath us, and we aren't tracking every single source. But yes, that's super interesting. And not only that, but like even before the JSON 5.0 format and stuff like that, the number of CVEs being put in has been dropping. Like the average, I think 6, 7 years ago was like 4. Now it's down to 2 or 3, 2 point something. And so we're seeing that drop. We're also seeing a drop in the effectiveness of the descriptions. The text descriptions are becoming more terse, more vague, and less context in there. And we do things with those descriptions. Right? And this is why we have to retrain the model. We have to go back every once in a while and say, refresh it. Let's try to learn from what we have now. And so the fact that I didn't know that MITRE and the CVE.org stopped doing that for CNA submitted ones. That's interesting. I'll have to go look at it now. Thank you. All right. No other. Did you have a question, sir? Okay. She's coming up behind you here.
Thank you. So I have two questions. First question is like talking about activities, right? Like the chatter. So like taking news, like articles like publish every day, and then, me and my team always look for, that's first thing we do in the morning, read the news and see what CVE is mentioning. And sometimes we kind of like head of CISA. So I know, okay, this vulnerability is making noise. It's talking about remote course execution. And then we kind of I know there's no plugin or any publisher by, Tenable or other vendors. But we look at it, okay, there's a software available for something, and then we kind of patch it, right? But the noise, that type of noise, can it be also inserted? Okay,
yes,
because the thing is, there's good people and bad people reading this, and they see this. Okay, it's talking about remote course execution is easy to do. So why don't they go through their community, whatever, and get that code and try to test it, what they see on the internet. So just seeing, can that also take that news to move a little bit of that, scoring?
Yeah. So essentially, like if you have a really noisy source like news mentioning CVEs, right? Is that helpful? And the answer is yes. not as much as it were if it were a clean data source, like it was more accurate. But essentially, think of something, I don't know, how about the user interaction none, CVSS 3.1 user interaction none. It's a green one sort of in the middle. I see it's bouncing around a little bit. If that's true, it's very noisy. There's probably a ton of CVEs that have that as true and less that have it as false. But something like that. So something though more like the chatter is a lot more variety than just a binary thing. But even in a binary thing, the machine starts to learn. This is the whole benefit of XGBoost. When it sees this signal, how good of a predictor does it become of this? And one of the benefits here is it says if we see this signal, and we see these three other things, that original signal now has different meaning. And so hopefully it's going to learn that. Sometimes a source is just like, what was one? Google Project Zero, and I don't want to pick on them at all, but I think they have 200 to 300 CVEs in their spreadsheet. That's actually a pretty terrible predictor. Like we don't see a lot of activity for those. Maybe Google Project Zero has done a great job and there's no more exploitation activity on. I don't know, but it's not a great signal. And the machine learned that and says, all right, if I see this, okay. So same thing on the chatter.
Okay. And my second question is, so like looking at those graphs and you see, if it's going up or down or staying steady. I remember last year, I saw like, one of those days I see straight and then suddenly like I see some other CV like jumped up. So I thought maybe, it may be like, it's finding something. So it's going up. But then another day I saw another CV has the same pattern. Then eventually I figure out that, the version changed and that's what increased the score. But I didn't know that until like, once I did more digging, researching. So I'm just curious,
right?
Is there a way like, can we tell, okay, what changes in changing this to this?
Yeah. So part of the challenge is we're a volunteer org. And right now we have basically one data feed. And so previously when we've updated the model, like one day it was V1 and the next day it was V2 and like a bunch of scores jumped around. On the web page, when you go to the data, it says very clearly when those dates are. If you go to the CSV download, it says these dates are when we changed. And like I had an academic paper sent to me and they did all this analysis about EPSS score jumping. And they're like, look at these jumps. And it was on the dates that the models had shifted. So I had to write them back, like, all right, sorry to tell you this, but so the challenge is because we're a volunteer org and we have basically no funding, what that's all we have is like one API feed and this. So realistically, it'd be great if we could say, here's how you request, version 2, here's our request version 3. We're adding version 4 in a month. You can switch over at your delight. That's not what we have. We have one thing, it's on or off. And so we're doing an update. We're working on one now. I don't know how we're going to roll it out because we've got so many more people depending on it. So it's been an ongoing discussion on the SIG. How do we do that? How do we note this stuff? There's a lot of opportunity to improve on things. So
Gotcha. Thank you.
Yeah. Next to you there.
Now you say that the model is actually generated from machine learning. And again, another assumption from my part, I assume that you keep feeding data into the machine learning all the time or frequently. When do it gets to a point, or when do you make the decision to say, well, based on the data, the model has changed enough now to go to EPSS version 4 or 5 or whatever? What is that cutover?
Basically, it's when I get enough time. That's when we're going to change over. Basically, like I showed that animation and we see that line sort of jumping around. Like if we watch that and we see that start to dramatically really drop, that's really going to increase the urgency to update. So we see it bouncing and we do see it is dropping slowly. Like if I made that more of a blended trending over time, you do see it dropping slowly. So we should be able to do it. Plus we've got a few more data sources I want to get in there. We should be able to improve on it. And so hopefully within the next 2 to 3 months, hopefully we can get a new model out there. I don't know how we're going to release it because I think people are going to be really upset if all the scores changed in one day or some subset changed. That might be a big splash. So I'm trying to figure that out. If anybody has any brilliant ideas, let me know to get that out there. Do you have the microphone? Oh, I can repeat it if it's short.
You said when I have the time, but will the rationale be also be an increase, whatever increase means, efficiency or an increased coverage, or what will be the logic to use to say, well, now, besides, I see that line dropping, what will be the reasoning to say I have to change?
So in those line plots, what we actually do is we calculate what's called the area under the curve. So like you pick any one line, so like we try to calculate these lines. When we get a line, we look at the area under it, and it's between 0 and 1, 0 and 100%. So like if the model is perfect in the upper right, you have 100%. If it's really bad, you have, I don't know, 0. And so like EPSS V1 was like a 0.27, 0.3 area under the curve. And so what we're trying to do is improve both the efficiency and coverage. We want to push that line in general to the upper right. And if the area under that, the space under it is bigger, that means we're getting closer to that right thing. And so that's how we measure and compare differences between different models and improvement and things like that.
Sorry to keep hoping, but what is the point on which it says, okay, the coverage under the line is 0.87. Well, now I have 0.88. It's time to switch. Or you say, no, I'm going to wait until I have 0.95. What is the moment that you say, I need to switch the model?
It's very subjective.
Okay.
There's very little logical. Like I said, it's more about timing and workload and volunteer effort, things like that. If it dropped like those 3 blue lines or so, like if that were steady, that was just like a blip in the data. That wasn't like a real thing. But if it dropped that far, I would make and find the time to update it, because that is too much of a drop from V3. The performance would be degraded, and I would want to get that back up with a new model. So right now it's sort of hovering around that top part. It's still way more effective than V2, but if it did drop, I would want to go back in and really go after it. And I think it's dropping enough where it's becoming more and more urgent with every passing week. So
changing gears a little bit, you were talking about data sources. How you guys, and of course this has privacy issues, but how you look into reaching to managers, security services, vendors, and see if there is any way to access that data, sanitized, of course?
Yeah, so from a privacy perspective, so largely we don't care who's being attacked, or we don't collect any IP addresses or company names or industries. I would like industry, that'd be interesting, but we don't have it. And so all we have literally is this CVE on this date saw exploitation activity from this source. That is all the data we have. And so we don't have anything personally identifiable or privacy or anything, unless the CVE gets offended that we're tracking it, but I don't think that'll happen. But that's all we have. So there's not much of a privacy thing there. And if a company does want to share data, and they try to include that stuff, we ask them to remove it. We don't need anything. We don't need host names or destinations or any IP addresses, anything like that. We just want to know that they have confidence that this was exploited on this day, by their source.
My comment was, as managed security services, as a reasonably good data source because of the coverage that they have. My question is, are you actively reaching out to possible data sources to improve the model, or are you waiting for somebody to show up and say, oh my goodness, this is great, let me give you my data?
That happens really infrequently. We've been trying to reach out. And as Sasha said, we were really surprised at a lot of the sources saying that they just weren't instrumented for what we were asking for. And don't want to call out any specific vendors, but I was really surprised at some of the vendors that we were talking to who finally admitted that. And in my day job, I work a lot with vendors and their data. And I think it's become a little bit funny, because we talk to vendors about their data and they're like, all right, I don't want you to, pass this on, but our data is really messy, right? It's like, of course it is. Like, that's how data is. Like, everybody says that, and so when we're talking to some of the vendors about the specific data, though, we're finding that they just aren't collecting it, which makes me a little suspicious, when I read blogs from said vendors and they're saying, hey, this is exploited in the wild. And I'm like, how do you know that? Like, did you read that somewhere else? Because you're not collecting it in your data. You told us so. So I don't know. It's very hard. But yeah, we try to reach out and we try to talk to different places. I think we've got numerous conversations at any given point, trying to track them and follow up. But it's very difficult. And a lot of companies want to know what they're getting in return, of course. Like, why would I give you this data? And that's part of the reason, too, that we can't release what's actually exploited, because that isn't our data. It's being donated. And if we did say, let me tell you what's exploited, for sure, no one else would give us our data and we'd lose all the data we have. Right. And so that's sort of the challenge that we're in for releasing that. So, but absolutely, like, and there's some companies that I've been surprised that are collecting data like that. Some really interesting possibilities we have coming up to find more information like that. And the more sources, the better. Even if it's tracking the same exact stuff, it's just more reassurance on what is actually being exploited.
So those other security companies, they have they have building their own VPR, scores. So the reason they have that score, is it because they have more data, because of the customer or the vendor? That's why they building their own and giving score.
I can't understand why they're. I mean, I get why they're building their own, because customers are asking for it. How they're building it and if they have more data, they write the blog posts like they do. I don't know for sure. And if I did know, I probably wouldn't announce due to things. But yeah, vendors do create their own, and they are also black box about what goes into it and things like that, just like EPSS is to some extent. They score different things. Do you need a mic?
They're not all trying to be a exploit prediction system. They might call it a risk score or a whatever score. So they would ingest different data in different ways. And so maybe that's useful. Maybe it's not.
Yeah, like they always mentioning some other model, but they don't mention the name what they're using, but they just putting machine learning model that we're using and other sources, but
Yeah.
it's like
That's what vendors do.
proprietary,
Yeah. And I've also wanted to do analysis on that, but of course, because it's proprietary, only customers get it. And so I can't really compare it or do any comparisons to, I think a few of those are probably highly correlated to CVSS, that they do a CVSS-like thing. But again, I don't have the data. I don't know.
We're getting down to our last 5 minutes, so we have time for just a few more questions.
Okay.
Okay. Thank you, everyone. Thank you for joining. Have a great day.